We talk about problem number 7 in the homework, which is in U substitution. So in this problem, once you finish observing the structure of the problem, you may realize that this term actually can appear multiple times. I can rephrase e to the 2x into e to the 2x to the power of 4. So my proposition here is that we set u to be e to the 2x. That is to say, du is e to the 2x, takes the derivative of the exponent, and that. Well, during the process of reformulating, you may realize this is my u directly. Minus 7 can be kept. 3 is kept. E to the 8x is something that's depending on e to the 2x, so I can rephrase that as well. So e to the 8x is e to the 2x to the power of 4. Therefore, it is u to the power of 4. So I can take care of this term as well. So the only thing left is dx. Well, I'm slightly worried because if you look at the structure, I have this extra coefficient in the front. But keep in mind the idea of u substitution is that you are capable of getting rid of all the x in your expression. So as long as you can express the function or to be something depending all on u, then we are good. So e to the 2x, I hope that look familiar to you. E to the 2x is u. So what I actually have, which I paused earlier, it's actually u times 2, so 2u dx. In other words, du divided by 2u is dx. So every time you see e to the 2x, it's u. Every time you see dx, it's du over 2u. Every time you see e to the 8x, it's u to the 4th. So by doing this for the reformulation, you are capable of rewrite your original function into a function that looks like this, and then 1 over 2u du, and you want to take integration. Well, keep in mind in this particular case, your u has already been changed, your variable has already been changed. Earlier, your x goes from 0 through 2, so currently your u, which by the way is e to the 2x, is e to the 2 to the 0 goes to e to the 2 times 2. In other words, e to the 0 goes to e to the 4, namely 1 goes to e to the 4th. So lower bound is 1, matching the position, and 2 leads to e to the 4, so this is what I end up with. So my problem now reformulated into something that looks like this. Well, it's a good time for you to pause the video and think how you can carry out this calculation, namely find antiderivative. Well, for this particular case, you could have simplified your structure. 3 over 2, u to the 4th over u squared is u squared, and then negative 7 over 2, u to the power of negative 2. So you can find the antiderivative of your function, hopefully relatively straightforward. Minus 7 over 2, 1 over negative 2 plus 1, u negative 2 plus 1, which is negative 1, evaluated at those 2 points. So you have 3 over 2 times 1/3, and then you plug in e to the 4th cubed minus 7 over 2 times 1 over negative 1, hence plus 7 over 2 e to the 4th negative 1. That's the first half of it, minus 3 over 2 times 1/3, 1 cubed, plus 7 over 2, 1 to the power of negative 1. Well, you can type in this as your final answer, or of course you could have mathematically simplified so it looks better. This is how we can choose the expression to do u substitution for problem number 7. So once you practice on a lot of types of different problems, you probably realize usually it's a common practice for a lot of problems to set up the denominator as your u substitution. Well, even if it's wrong, I mean, it's just a basic attempt, right? So you can try something else later. And this one is very interesting or slightly trickier than the others is because during the process of transformation, you realize the connection between du and dx, even though it seems like to be depending on x, it's actually after rephrasing, it's actually going to be depending on u. So you are still capable of rewriting every single term you observe that's x dependent in your original function into u dependent. So you can still solve that.